Welcome back to Geometry, Measurement, and Probability. In this section, section 12.2, we will continue talking about congruence for triangles. So let's get started. In our last section, we talked about side, 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 and we also talked about side, angle, side. In section 12.2, we look at two more congruence theorems for triangles. We have angle, side, angle. So if we have two angles and the included side of one triangle congruent to two angles and the included side of another triangle, then our triangles are congruent. Look at the example below. Notice we have two triangles. We have an angle, then a side, and then another angle marked as congruent. So we have angle, side, angle, then these two triangles would be congruent. Our next theorem is angle, angle, side. So if we have two angles and a side opposite these angles in triangles, that means that our two triangles are congruent. So if you look at our two triangles here, we have angle A and angle D are congruent. We have angle B and angle E are congruent. And then we have the double hash marks to show that the side is congruent. So again, we have an angle, and a side. Example 1 asks us to show that our two triangles are congruent. So let's start thinking about the pieces of the triangles that are congruent. Well, first, I notice that angle B is congruent to angle E. They both measure 70 degrees. Then I notice that angle A is congruent to angle D. They both measure 40 degrees. I also notice that side AC is congruent to side DF. They measure 6. Notice the segment symbol above my sides. I have an angle, and a side. And so triangle ABC is congruent to triangle. Remember, our matching pieces need to be named in the same order. How we name the first triangle doesn't matter, but I do need to pay close attention to how I name my second triangle. Angle A matches angle D, so we have D. Angle B matches angle E, so we have E, and then C and F match. And so these two triangles are congruent by angle, side. Look at example 2. Again, we're asked to show that our triangles are congruent. So let's start thinking about the pieces of information that we know. Angle ABD is congruent to angle CBD because both of these measure 70 degrees. I also notice that my triangles share a side, the side BD, and so BD would be congruent to itself. And then angle BDA is congruent to angle BDC. They both measure 50 degrees. So I have an angle, a side, and an angle. How you name your first triangle doesn't matter, so I'm going to name it triangle ABD. Then as I start to name my second triangle, I need to name the matching pieces in the same order. A and C match, B and B match, and D and D match. These two triangles are congruent by angle, side, angle. Look at example 3. We want to know, are our triangles congruent? Why or why not? And if they are, we're going to use the appropriate notation. So again, let's start thinking about the pieces of information that we know. Well, first, I know that angle AND is congruent to angle BNC. These are vertical angles. Then side ND is congruent to side NC. That's given by the hash mark. Then last, I notice that I have parallel lines. Line AD is parallel to line BC. So alternate interior angles are congruent. That means that angle ADN is congruent to angle BCN. So I have an angle, a side, and an angle. And so triangle ADN, remember I can name that first triangle in any order, is congruent to triangle. And as I start naming my second triangle, I need to name the matching pieces in the same order. A and B match, D and C match, and then N matches itself. And these are congruent by angle, side, angle. Look at part B. We know here that angle Y is congruent to angle L. This is given to us by that mark in the angle. Angle Z is congruent to angle M. These are both right angles. I have an angle and an angle, but this is not enough information for me to decide whether or not these two triangles are congruent. Example 4 starts looking at what we call proofs. Now, we've been doing a simplified proof as I write out my reasons for each step. A proof is more formal, and we make sure that we write out everything we're given and everything we know, and we write our reasons with each of those. So let's start by looking at the information we're given. The problem tells us that angle A is congruent to angle D. I'm going to go ahead and put my marks in those angles. The problem also tells us that side AO is congruent to side DO, and I'm going to put my mark on that side. I have an angle and a side. I need at least one more piece of information. I have some vertical angles, and vertical angles are congruent. So angle AOB is congruent to angle DOC. Now I have an angle, a side, and an angle. So my triangles AOB and DOC are congruent by angle, side, angle. Let's look at another example. In part B, we're again asked to prove that our triangles are congruent. When we have a proof, we almost always start with the given information. So I'm going to say that we are given that side AD bisects side BC and that side BC bisects side AD. So what does bisect mean? Well, bisect means cut in half. Now we're told that BC bisects AD, so BC cuts AD in half. That means that AO is congruent to DO. We are also told that AD bisects BC, so it cuts it in half. That means that BO is congruent to CO. I'm going to go ahead and place my marks on my triangle. I need either a side or an angle to be able to tell that these two triangles are congruent. Once again, I've got some vertical angles. Angle AOB and angle DOC are congruent because the vertical angles are congruent. And I'm putting my mark in my triangle. So I have a side, an angle, and a side. That tells me that my two triangles, AOB and DOC, are congruent by side, angle, side. This brings us to parallelogram congruence. The opposite sides of a parallelogram are congruent, as are its opposite angles. Now, there are some properties of quadrilaterals. Be sure that you read through these properties of quadrilaterals that are in your notes. There are properties for trapezoids, for isosceles trapezoids, for parallelograms, rectangles, kites, rhombi, and squares.